Weather. It's a little more than a smidgen. That was a pretty good slide. Hello and welcome to Weatherwise. I am your host, meteorologist Nathan Scott. This week we're talking about what happens when you have a deck of cirrus clouds in place. It can create some pretty interesting optical phenomena that you may or may have not seen before. Then we'll switch gears over to types of winter precipitation. Why do we see rain versus freezing rain versus sleet versus snow? And speaking of winter precipitation, you may remember 4 years ago, we had a lot of snow here in central Arkansas. We'll recap on how much Snowmageddon produced back in 2021. Let's talk about, first of all, the optical phenomena situation when you have a deck of cirrus clouds that can play with the sun's light. Like this photo behind me. Now you see, we have lots of cirrus clouds, but those cirrus clouds are made of ice crystals. And when sunlight goes through ice crystals, some pretty cool phenomenon can happen. You look at this, it just looks like a pretty plain picture. You got the sun about to set, you got the deck of cirrus making its way in from the west most likely. And then if you take a close look, you see this little, almost tiny bit of a rainbow. That actually has a name, and it's called a sundog. Why does a sundog form in the first place? Well, it all has to do with visible light going through ice crystals that causes the light to bend and produce that effect. So let's talk about the physics behind light. You probably remember this, 5th grade, 6th grade science. You have a prism, you shine a light through the prism, and what happens? That light disperses or breaks up into the color spectrum, which we're all familiar with. Roy G. Bibb, at least that's the way I learned it. Red, orange, yellow, green, blue, indigo, and violet. And anything can produce refraction, and that does include raindrops, hailstones, and also snowflakes. So with those objects in the atmosphere and the sunlight going through those objects, we do have some pretty cool results. You should know this one, because what happens when you have, say, the sun in the western part of the sky and you have rain in the eastern part of the sky, and that sun is going through those raindrops? Well, as the sun goes through those raindrops, the light bends, it refracts, produces the visible spectrum of color, and then as that light bounces off the backside of that raindrop, it's known as internal reflection. It comes back out on the other side of the raindrop and produces a breakup of those colors, and that of course results in a rainbow. And for this to happen, the angle has to be around 42 degrees if you want to get more deeper into the science. So when we take a look at rainbows, there's something you may not have noticed before. Yes, it's beautiful, and of course the red shines much more brighter than violet, and actually sometimes there's 2 times that the light gets reflected, and that produces a double rainbow above the primary rainbow. And with a double rainbow, the colors are reversed. So instead of red to violet, it's violet to red. What you also may have never noticed is when the sun, let's say for example, the sun is setting in the west, about to set, and of course you have the rainbow in the east. But have you noticed the arcing nature of that rainbow is much higher? When you have the sun angle very low, close to the horizon, your rainbow is going to be much higher, reaching higher and higher above the horizon. The opposite happens when you have the sun higher above the horizon. That arc of the rainbow is going to be much lower, as seen here. So with that said, can you ever see a rainbow, say around noon or 1 o'clock in the afternoon? And the answer is no, because the sun angle can never be higher than 42 degrees. If it is, the rainbow is below the ground. So you may be able to see it from an airplane, but down the surface, you'll never see a full arcing rainbow in the middle of the day. And when we mention 42 degrees, This is an astronomy lesson that we always use as well when we're trying to find planets or a constellation. You just hold out your fist to the horizon like this. This is 10 degrees. This is 20, 30, 40, 50, 60, 70, 80, and of course 90's straight above you. So that 40 degrees, that sun angle can only be about that high for a rainbow to happen. So of course with a rainbow, you need the sun to be out for a period of time, and then you got to have rain or snow on the opposite side of the sky for the sun to go through the snowflakes or raindrops and produce that effect. I mentioned at the top of the show, we didn't discuss just rainbows, we discussed what a sundog is. This is a special case. Cirrus clouds are made of ice crystals, but not all ice crystals are those pretty snowflakes that you cut out with construction paper or that you are familiar with, the six-sided dendrites. There are other ice crystals that happen dependent upon the temperature of where they form. And we have something known as hexagonal ice crystal plates. In this type of situation, it's very unique. The sun will go through those ice crystal plates, and then as we're looking through those plates, of course, the sunlight is bent or refracted, and it produces this effect where you have that little piece of almost like a rainbow on opposite sides of the sun. So next time you see a sundog, look for not just the one on the left, but also the one on the right. These are also known as mock suns. Sometimes they don't have a color to them. Sometimes it just looks like a very bright part of the sky and almost kind of looks like another sun. At least that's what it did when the Indians saw this back in their time. For this to happen, the sunlight has to be at a particular angle going through that crystal, and that's 22 degrees, just to be a little more scientific. And sundogs, they don't last a long period of time, 30, maybe as much as 45 minutes. But as the sun angle changes, of course, you're not going to have that perfect angle to take place through the ice crystals, and therefore those sundogs will fade away. So next time you see a deck of cirrus clouds, look towards the sun right before sunrise, or before sunset and after sunrise, and you may see a sundog. We'll talk about winter precipitation coming up next here on Weatherwise. February, it's still winter. We're still talking about the potential of winter weather here in Arkansas. But what happens when we're trying to forecast on what type of precipitation we're going to get in the first place? Well, all is determined by pretty much not only what's happening right at the ground, but what is the temperature profile as you get higher and higher into the sky, into the clouds. So let's break it down here because we're looking at the temperature profile from the ground all the way up to the cloud. And the easiest one to nail down is when you have a temperature profile of 32 degrees or lower from the cloud all the way to the ground, it falls in the form of snow. And of course, when you have the opposite happen, meaning you have the temperature profile above 32 degrees from the cloud all the way to the ground, the precipitation falls in the form of rain. Then things get interesting, because as we get into sometimes with the storm system, we may have Arctic air in place. Arctic air is heavier. Warmer air is lighter. And if you have warm air in place and then you have this shallow wedge of cold air that pushes its way right along the surface that may only be 1,000 feet deep, that's when you will not just have rain, but you'll have other types of precipitation, such as sleet or freezing rain. So when we take a look at the next occurrence, we have snow. It's snowing in the cloud, but this red triangle is showing us where the temperature is above 32. Those snowflakes melt, they turn into raindrops, and if we have a very shallow layer of sub-freezing air, that precipitation will continue to fall in the form of rain and then freeze on contact. That is what's known as freezing rain. And it creates a glaze of ice over everything, over steps, power lines, trees, That's what can cause massive ice storms. And you can have freezing rain. Your temperature at the surface may say it's 25 degrees. And this is what I always used to wonder when I was a kid, because I always thought it's 25 degrees, this should be snow, why is it raining? And I used to get so upset because I wanted to go sledding, but we had rain and I didn't realize what was going on until after the storm passed and you walked down the steps and I pretty much fell down and got a good taste of, okay, this is freezing rain producing an ice skating rink on the steps. So freezing rain can happen when it's in the 20s on the surface. And that's because about 5,000, 6,000 feet above the surface, temperatures could be in the 40s and 50s. But if this wedge of warm air is a little bit more narrow and the colder air is going to be deeper, you have snow, that snow melts, and as those become raindrops, the raindrops start to make their way through the sub-freezing air. Those raindrops freeze and become ice pellets, or what's known as sleet. And sleet is much easier to deal with because it just bounces off things. It's a pellet, it'll bounce off cars, bounce off your face, it'll sting your face if you're out, but it doesn't coat everything in ice. It doesn't coat roads in ice, it doesn't coat power lines and trees. It can still make for some big impacts, but certainly the impacts of sleet are going to be not as severe compared to freezing rain. And we continue to, of course, watch here on THV 11, looking at what types of precipitation we're expecting, because we have weather balloons that we launch all across the country, all thanks to a lot of the National Weather Service, that will give us an idea of what the atmosphere is producing. But also forecast models, Storm Track 11 now, shows what the atmosphere could look like in the future. And that's what is a beautiful thing about forecast models, because if we were to launch a hypothetical weather balloon, this is for the Ozarks. And what I want you to notice is the red line, okay, that is going to be the temperature line. The green line, that's the dew point line. And where these two meet, you have 100% saturation. So more than likely, it's going to be definitely producing precipitation, and your cloud deck is going to be all the way up to 500 millibars. But what I want to focus on, and this just changed on me, so let me go back and choose another one here, because it was showing the warm air a little bit more. So here we go. This blue dotted line, this blue dashed line, if you follow my cursor right there, that is the freezing line. So what we're watching is as you go up above the surface, the temperatures are below freezing. But then once you get around 900 millibars, which is going to be almost about 2,500 to 3,000 feet, the temperature starts to go in the opposite direction and starts to warm. And just below 850, which is about 5,000 feet above the surface, your temperature profile is now going to be above freezing all the way up until 700 millibars. And that's almost about 10,000 feet. So between 5,000 and 10,000 feet, your temperature is probably, looks like at max, almost 42, 43 degrees Fahrenheit. So therefore, it's snowing in the cloud, and once again, it's going to encounter that warm air, so that snowflake melts, or the snowflakes melt, turn into raindrops, but right at the surface, you're at 32 degrees, and there's the potential of freezing rain. So it's only 1 degree difference, not only just at the surface, but what's happening also just above the ground. So there's going to be pockets of freezing rain in this part of the state looking at this situation. Freezing rain, it accretes or produces ice on trees, on power lines, when it's freezing drizzle or light freezing rain. If the freezing rain's too heavy, if you have heavy freezing rain, then the situation will be much better because the ice won't be able to accrete. It just is pretty much almost stays liquid. The ideal conditions for an ice storm would be drizzle or a light freezing rain, maybe a moderate freezing rain. So hopefully we don't have any freezing rain for the rest of the winter, but we still have some time to go. We have all the way through March. We could still get winter storms here in Arkansas. We'll wrap things up here on Weatherwise, talking about 2021 and how much snow was produced in about 1 to 2 weeks' time. Stay tuned. Where were you 4 years ago? You were probably watching us here on THV 11. We were talking about the potential of heavy snow impacting central Arkansas, but we did not know that we were going to have not one, but two storms that just gave us a pretty good uppercut when it comes to snow here in the natural state. The first storm arrived February 14th through the 15th. It canceled everybody's Valentine's Day plans because you were pretty much going to be stuck indoors. It was the combination of not just the heavy snow, but bitterly cold temperatures that stuck around for a long period of time, and that just shut everything down across central Arkansas. A lot of the interstates didn't open for at least a few days. I was here at the station, seemed like for almost a week. Well, let's talk about those snow totals that did come in with storm number one, and it was a corridor of 8 to 10 inches, more than that, right through the I-30 corridor from Texarkana, Arkadelphia, Hot Springs, here in Little Rock, also all the way up through Faulkner County, Cleburne County, even reaching into Clinton and Searcy. But it was a wide swath of heavy snow. And remember, here in Arkansas, on an annual basis, our average is about 3.5 in central Arkansas. So we already surpassed the average after this storm system. It was lesser amounts into northwest Arkansas, 4 to 6, Fort Smith, Fayetteville, Harrison, also Clarksville, and then also 4 to 6 across the eastern half of the state and southeast Arkansas. But everybody got snow across Arkansas. No one missed out on storm number one. Now, storm number two, that really gave us a while up. And I remember looking at radar that day, and I couldn't believe the snow rates that were happening around Pine Bluff, around Grant County, into Arkadelphia. It seemed like snow rates were 2 to 3 inches per hour, and you looked at the iDrive cameras, and it was certainly whiteout conditions in that part of the state. The bullseye, the core, went right through south central Arkansas and also central Arkansas. Lesser amounts into the Ozarks. What a surprise. Typically, they are the jackpot winners. It was 2 to 4 from Clinton, Batesville, Mountain Home, Harrison, Fayetteville, Fort Smith. Even lesser amounts, Mena, stretching through the River Valley, Russellville, Clarksville, into parts of Johnson County. And then those amounts really started to trail off once you got into South Arkansas. Once again, though, everybody had snow across Arkansas, and that arrived February 17th. So it was back-to-back blockbuster storms that really impacted us here in Arkansas. So the grand total for both of those storms, February 14th through the 18th, were just left you speechless for the most part. The most snow that we've seen on record in February for a lot of locations. Little Rock ended up with over 20 inches of snow from both of these events. There was more than almost 2 feet of snow in parts of Jefferson County, Grant County, Hot Spring County, through Clark County, and right through almost the I-30 corridor. And then 6 to 10 southeast Arkansas, 10 to 14 West Memphis, Searcy, Clinton, Heber Springs, Mountain View, all the way to Mountain Home, stretching back into Mount Ida, and then 6 to 10 were the grand totals for northwest Arkansas and also North Arkansas. When you have fresh snow cover on the ground, once this moved out, we had a polar vortex move in, or some bitterly cold air just set up shop across the state, and the snow did not melt for a long period of time, so everything just stayed iced over. And once the sun set with clear skies, we had perfect radiational cooling because all that little heat that we saw escaped right back out into space. And that set up the stage for bitterly cold conditions, record cold across the region. We did not see these numbers until the 1980s is the last time we saw temperatures drop below zero here in Little Rock. We got down to 1 below zero in Little Rock, 3 below zero in Malvern, 8 below zero in Conway, 20 below zero in Fayetteville, 12 below zero in Marshall, and that led to a lot of freezing pipes. And then once we started to thaw things out, of course, we had to deal with issues with the pipes bursting, and that did include like the Museum of Discovery and other locations. So hopefully we don't see anything like that for the next several years, but that tells you it does snow here in Arkansas, and sometimes we do get walloped with some heavy amounts of snow, even though the years before we didn't really see much snow until February 2021 arrived. Well, that's it for WeatherWise. Always thank you for watching, and if you have any questions, please let me know. If you have any weather topics that I have yet to cover, all you have to do is go ahead and send an email to us, nscott@thv11.com. You can also reach me on my Facebook page. Just go ahead and put in search engine Nathan Scott THV11. I'm very easy to find. I've got some great topics coming up for spring. We're going to be talking about severe thunderstorm warnings, severe thunderstorms in general, what creates a severe thunderstorm in the first place, what creates tornadoes, and going into severe weather season, we have some really great stuff that you would love to know, and hopefully I'll be talking to a storm chaser on his career as a storm chaser coming up as we get into severe weather season. Thank you once again for watching. I'm meteorologist Nathan Scott. Have a great day.